Hi, my name is Massimo Refere. I'm a principal technologist in the AWS container team, and in this session I would like to present you a new feature or a new capability of Amazon ECS called Amazon ECS Anywhere. The content in these 30 minutes is divided in two major blocks. In the first block, I would like to present you a few slides to create context around this feature, why we're introducing it, why customers are going to be interested in it. In the second block, in the second part, we're going to see a live demo of how this capability works for real. So let's get started. So in this deck, you will hear me talking about the control plane and the data plane. So that we are all on the same page, let's talk about what they mean in the context of this deck. So the control plane, which Amazon ECS represents, is the service that you're talking to as a user, as a developer, to say, can you please start this task for me? The data plane is essentially the place where that task is going to come to life. In general, when you start an ECS task, it gets started on either EC2 or Fargate. But we will see how this can change with Amazon ECS Anywhere. So before we dive into this, let's go very quickly through why customers are using ECS and what they like about ECS. A lot of customers like the simplicity of ECS. So this notion about no ops, or the fact that the control plane is fully managed in the cloud, saving you from the burden of managing a complex system. The other reason is because ECS is very developer friendly. And here I would like to talk about and mention some of the advancement that we have made in terms of the AWS CDK, the Docker Compose integration that we built, or Copilot, a new CLI that allows you to deploy ECS services very rapidly. Last but not least, ECS is enterprise grade. Lots of certification, particularly for those customers working in regulated industry, for example. Amazon ECS guarantees all of that. The number of ECS customers that are using the service is also growing because of this reason. They all appreciate how simple it is to start and evolve the usage of containers on AWS using Amazon ECS. Let's now dive more into the data plane expansion, or the data plane evolution, if you will, of Amazon ECS over the years. When we introduced ECS back in 2015, the only option to deploy task or ECS services was in the AWS regions. You could deploy them either on Amazon EC2 or AWS Fargate, but you were limited to deploy those tasks and services in regions. Then customers have started to ask us all sorts of ways that they wanted to use to innovate for their own customers. So these customers ask us how we could lower the latency for their own users to connect to applications deployed on Amazon ECS. Some customers also ask us how they could deploy ECS workloads in their own data centers on AWS managed infrastructure. Other customers were asking us how they could take advantage of the new 5G network that we're starting to see coming to life. That's how we increase the flexibility of the data plane for Amazon ECS by introducing support for things like, for example, AWS Wavelength, AWS Local Zone, or AWS Outpost. In particular, AWS Outpost is a new service that allows customers to use AWS managed infrastructure inside their data centers. Customers have been asking us even more. Customers came to us with additional challenges and additional features that they would like to have from ECS. The very first thing that was clear for these customers is that they wanted a single operational model regardless of where they were deploying their workloads. So if they had to deploy their workloads on-prem in some customer-managed infrastructure, they didn't want to use two different APIs and two different systems to deploy containerized application on AWS as well as on-prem or in any other situation where they could not source AWS managed infrastructure. Some of the reasons for which they needed that was, for example, CapEx investment. Some customers may have done some investment that they needed to use, and they couldn't just go straight into the cloud. Other customers have requested that we would support, for example, customer-managed infrastructure because of compliance requirements. Some customers operate in very regulated industries, and they may have peculiar requirements that they require having them to manage the infrastructure instead of AWS. Last but not least, as we know, data gravity exists and data is everywhere. So they were asking us for more flexibility to deploy ECS applications closer to those data, wherever those data are. So typical questions that our customers were asking us were, can I use ECS with infrastructure that I own and I manage, maybe for those compliance reasons that we were alluding to? Or other customers, again, as I mentioned, they ask us, can I leverage the simplicity of Amazon ECS with the existing capital investment that I have done in my data center? In summary, a lot of these customers were asking us, can I use Amazon ECS to deploy anywhere? And I guess that we took advantage of this specific question to introduce this new capability, again, ECS Anywhere. So next year, we're going to enable Amazon ECS customers to deploy their ECS workloads on customer-managed infrastructure, in addition to all of the other options that we have seen in the previous slides and that you can see still on this slide. Now that we have talked briefly about how the reason for which we're introducing this feature and why customers have been asking us to introduce this feature, let's talk very briefly about how it works before jumping into the demo. So this is how, at the very high level, Amazon ECS Anywhere works. So the Amazon ECS control plane will remain in the cloud. Okay, this is the very first tenet. What we want to do is we want to enable customer-owned infrastructure that you can see on the right-hand side to be able to accept ECS workloads on it. So the very first thing that we need to do is to make that infrastructure aware of the AWS cloud, and similarly make the AWS cloud aware of that on-prem customer managed infrastructure. The way we do this is by using SSM, so that or AWS Systems Manager, and allow that infrastructure to become managed instances inside AWS Systems Manager. This also allows this on-prem infrastructure to create a secure connection back to the cloud so that they can make authenticated calls with temporary credential to the cloud. The second step is to deploy the ECS agent, or an evolution of the ECS agent, on this customer-managed infrastructure, so they become akin to the EC2 instances that you have in the cloud and in the region today. So they become part of an ECS cluster that you have previously defined in the region. We will talk more about this when we show the demo. Last but not least, this will allow you to deploy Amazon ECS workloads, for example, an ECS task, on this customer managed infrastructure, maintaining all the capabilities of ECS native task, like, for example, talking back to AWS services and allowing customer to deploy applications that take advantage of that. So let's go through the 4 very key architectural tenets of Amazon ECS Anywhere. As you see in the footprint, this is still in development, so some of these may change, but this will give you a high-level understanding of how we're thinking about building ECS Anywhere. We have already talked about this, but it's important that we keep this in mind. The ECS control plane remains in the cloud. And this is to take full advantage of a fully managed control plane that you don't have to revision or you don't have to upgrade. Everything that we do in the cloud, you will see on-prem on this managed infrastructure. Only information for managing the lifecycle of the ECS task and ECS services is going to be sent back to the ECS control plane. This includes things like the status of your containers or the health checks of your containers. None of the information that exists inside those containers are going to be pushed back into the ECS control plane. The other thing that is important to understand is that ECS Anywhere is infrastructure agnostic. We don't really care where the SSM agent runs as long as it's running on a supported operating system and devices. But the idea is that you could run these on virtual machines, a bare metal servers, or all the way to Raspberry Pis if you wish. Last but not least, in disconnected scenarios, ECS Anywhere tasks will continue to run unless obviously you need connectivity back to the clouds for consuming other AWS cloud services. The other thing that you wouldn't be able to do in disconnected scenario is to lifecycle those tasks, like starting them, stopping them, or updating those tasks, because this requires connectivity back to the control plane, which, as we said, only exists in the cloud. So now that we have a basic understanding, let's go and talk a little bit about how the demo is going to work. We will briefly switch into the demo, but I wanted to give you an overview of how this demo is going to work and how we are going to leverage Amazon ECS Anywhere. So I built a very basic Python application that you can see in this slide running in that ECS task that in the cloud has been instantiated on AWS Fargate. That application is built in a way that it will read from a queue that we have defined in Amazon SQS, and it will act upon files or data that are hosted on an EFS share. Last but not least, this application also reports and logs that activity into CloudWatch. So the flow of the application is data come in that EFS share, in particularly in a source folder, for example. New messages come into the Amazon SQS queue for informing the application on which files it needs to act upon. The application will read from the queue, and if there is a match between the message that is coming in the queue and the file name in the source folder, it will take that file and it will operate on that file. So basically here what I'm mimicking is a process that takes data, work on that data, and move that data into another folder like a destination folder. Last but not least, this application, this Python application through the Boto SDK will log into Amazon CloudWatch what it has done. Now, this has been deployed in the cloud, but imagine that you are a customer that built this architecture but you're also deploying this worldwide, and you have maybe a few countries that have particular regulations that won't allow you, at least initially, to bring those files into the cloud on that EFS share. So you need to find a way to run that application closer where the data is on an infrastructure that is managed by the customer. So this is how we're going to show Amazon ECS Anywhere in action. So basically the idea is to use the very same flow that we have seen so far, that I've depicted a minute ago, but instead of doing everything in the cloud, we're going to deploy the task on customer managed infrastructure and the data that reside on an NFS share in the customer data center. So that's what we're going to demonstrate in the demo. Let's switch into the demo now. So this is, I have already deployed my application in the cloud, and what you see at the bottom of the screen are a representation, an SSH session, into the two instances that I'm going to use to deploy my application. These are running somewhere in my data center. At the top of the screen, there is a console that I'm going to use to run a main script. This has nothing to do with how we're going to deliver this capability when we make it generally available, but it's just a script that I built just to show you in a demo-like environment the steps that you need to take in order to set this up. The first thing that I'm doing with this script is I'm setting some environment variables because I'm using a development environment because this capability is not yet in production. So you will see in a second that I'm setting these environment variables to point to this development environment, as you can see here. The next thing that I'm going to do using the traditional Amazon ECS APIs is to create a new cluster. As you can read from the text, I'm creating an ECS cluster called external. That's the name of the cluster. The next thing that I'm going to do is to prepare these two instances following the architecture that I've been showing you in the slide. So I'm going to install the SSM agent, and the first thing that I need to do is to create these SSM keys in order to be able to register those two instances back into the SSM service. So I'm generating these keys and I'm outputting these keys onto the console momentarily so that you can take those keys, the activation ID and the activation code that is part of the keys that we have created, and now I'm going onto these instances to install the SSM agent. I'm going to prepare these two instances by exporting these variables. Note that I'm also exporting the cluster name variables that has been populated with the name external because that's the name of the cluster. So on these two instances, I already have another script that just installed the SSM agent. So let's run this script on these two instances. So this script doesn't do anything other than installing the snap of the SSM agent because I'm using Ubuntu on these two instances. And that's how I decided to install the SSM agent. The next thing that this SSM script does is to register those agents into SSM using this activation ID and activation code that I've just exported. So it's completed. So now that instance A has been registered, I'm going to skip the instance B because it's basically the same thing in the interest of time. So I'm going to go back to my main script. The next phase is to ask SSM, let me know if you see a new managed instance. And SSM is responding, yes, I see these two new managed instance. If you look at the bottom of these two JSONs, you will read instance A and instance B, which are the host name of these two instances that you see at the very bottom. Now that I have the SSM agent installed on these two instances, I want to take advantage of SSM distributor to deploy the ECS agent on these two instances. Because the ECS agent surfaces to the user as an ECS agent container, what I'm going to do on these two instances is I'm going to watch a Docker PS to make sure that this agent comes up, which means that the ECS agent has been properly installed. This will take a few minutes, so I'm going to cut also this part of the video. But as you can see, I have already triggered SSM distributor to install that agent, that package on these two instances. We will come back when these two instances are, or the agents are up and running on these two instances. As you can see, now the ECS agent is running. As you can see, there is an ECS container agent running on these two instances. If I use the Amazon ECS API to query the external cluster, I see that that cluster has two new container instances that are represented by those two instances. If I flip to the UI, I see the very same thing. So if I refresh the UI, I should see a cluster called external, which is the cluster that I've just created with that script. And I see two container instances, which are those two Ubuntu instances that you see at the bottom of this screen. So at this point of the demo, we're at the point where we can actually start deploying our application on these two instances over here. In order to do that, I have prepared a JSON file that represents my task definition. And this task definition points to the SQS queue, for example, that I'm using in the cloud, because that's what I want that application to point to. So I'm going to create a new task definition. This is what you see here is a development version of the AWS or the Amazon ECS console. As you can see, there is a new launch type called external. So when you create a task definition, now you have the option of creating a new task definition or a new task of type with a launch type external, which is new in addition to Fargate and EC2. In the interest of time, I'm just going to copy and paste that JSON instead of filling the UI. But this is the JSON that represents my task definition. This is going to point to the same container image that I'm using in the cloud. I'm going to create this task definition. And the next step is to start this task definition. One thing to note here is the task role. The task role that you see here is exactly the same task role that I'm using when I'm deploying a task in the cloud. And that task role includes the EM capability to connect to that SQS queue, for example. As you can see, the compatibility here is external. And that's the container image that I'm basically including in the task definition. So the next step is to run this task. Let's run this task, and again, there is a new launch type here. In addition to Fargate and EC2, there is a new launch type called external that represents capacity that is not managed by AWS. So I'm picking the cluster external. In retrospect, I may have opted for a different name, not to create too much confusion, but external here is a fantasy name. The cluster name could have been whatever. So the task has been run. It's in pending, so it will take a few seconds to come up. It's still pending, but now it's running, right? So if I go back and I check on those two instances, I see I'm still watching the Docker PS. I see a new container coming up. And that container is the container that was defined in the task that I just launched externally on the cluster. So now that I have my application up and running externally, let's show how that application actually works, because I didn't want to stop to the point of just launching a task. I just want to show you that that application actually works. So these two instances have a data directory that you see here that is a mount from an NFS share. So that data directory on both instances includes a source folder and a destination folder. As you can see here, the source folder is empty. I'm going to show you that that source folder doesn't contain anything. The destination folder has a few files that has already been processed because I have already been tested this application previously. So I have an empty source folder and the destination folder that has some files in it. One thing that I'm going to do now is I'm going to watch the source folder so that we will see during the demo that files are moving back and forth. So I'm watching on the left-hand side the source folder. As I said, the data directory is actually a mount, so I'm saying the very same thing on this other instance. So I'm going to create some files on the destination folder on the very same network share. So I'm going to create files called 001, 002, 003, and 004. There was a mistake that I made when I recorded this, in that I created the files in the directory that was not where I intended to create those files, because I created them in the root of the data directory, whereas I need to create them in the source folder. So I'm fixing that. Sorry about that. So I'm creating 001 and all these other files in the source folder. As you can see, they are popping up on the left-hand side because I'm watching that folder over there. So what I'm doing now is I'm going to watch the destination folder on the right-hand side. Just by doing a watch ls -la on the destination folder. Again, the destination folder has already 5 files in it. But what I'm going to do now is I'm going on the SQS console and I'm going to inject messages and put messages into that queue that match my file's name. Basically, I'm telling the application, process files 001, 002, 003, 004, and 005. Those are the messages that I'm putting on the queue. The Python application is continuously reading that queue, and if it finds a match between the message and a file name, it will start processing that file. As you can see, files are already starting moving from the source folder into the destination folder. Again, the logic of this application is very stupid. It just takes a file, it renames it and moves it to another folder, but hopefully it gives you an idea of some computation that your real-life application may be doing in your data center, for example. So as you can see, all the files have been moved from the source folder to the destination folder. Last but not least, I wanted to show you that that task is still logging into CloudWatch, regardless that it's running on-prem, on customer-managed infrastructure. That task is a native ECS task, so that task is logging into CloudWatch that it has been processed file 001, 002, 003, and 004. So this is basically what the application is doing in the cloud, but it's now also being able to do it on customer-managed infrastructure. This concludes the demo, and we will go now back to the slide with a little surprise. Okay, hopefully you enjoyed the demo. I said that I had this little surprise. Some of you may have been wondering what were those two instances that I've been using for the demo, the two red screens that you saw at the bottom. They could be anything. They could be virtual machine, they could be bare metal. As you can see on this slide, I have actually used 2 Raspberry Pis to do that. These are actually the 2 Raspberry Pis that I've been using. So a surprise on a surprise. I didn't even bother to connect those 2 Raspberry Pis to my home network. I just use wireless. So that application that you saw me running and talking back to SQS and logging into CloudWatch and acting on a local file share, they were doing all of that via wireless on my home network. As I said during the presentation, when we GA next year, we will be more precise in terms of which operating system we will be supporting and which infrastructure we will be supporting, but the technology allows for that flexibility. Call to action before we close this. If you want to know more and if you want to be if you want to stay up to date in terms of what's going on with Amazon ECS Anywhere, please subscribe to that URL that you see in the very first bullet. The other thing that I want to say is the demo that you saw is a cut down version of a longer demo that I have with a lot more details that also talk about the cloud deployment and how I have been reusing pieces of that cloud deployment like EM roles and other things for the on-prem deployment. The demo that you saw in this session was very much focused on just the on-prem deployment, but if you want to have the end-to-end picture, just watch the extended demo that is embedded in the blog post on the container blog. With this being said, thank you very much for sticking around. This is my Twitter handle. If you want to reach out, if you have any question or feedback or anything, we would like to hear from you. Last but not least, remember to complete the session survey because we are very interested in understanding if we are serving you well with these sessions, and we want to hear if you have any feedback. Thank you very much, and thanks for coming.